Hello and welcome to my channel again. In today's tutorial we are going to talk about the science of uncertainty, which is mastering hypothesis testing. In the world that we are today, we are full of guesses or uncertainty about an event or about an occurrence or about an experiment or trial. In order to make right decision, we need to make use of hypothesis testing to make right decision, because guessing on certain experiment or making assumption without substantiate the fact can lead to wrong implementation. In this tutorial, we are going to talk about hypothesis testing, which is a science of decision making when you are not sure about an event. In this wise, hypothesis testing comprises of two types. We have null hypothesis, alternative hypothesis, in which decision can be taken by using a certain level of significance. The certain level of significance can be either 1%, 5%. It depends on the requirement of the question or the requirement of the experimentalist. What is alternative hypothesis? This is initial guess or question raised about an experiment or trial. While the alternative hypothesis, as you can see, is referring to as a contradictory statement to our initial guesses. When you say something initially, or when you consider something, or you thought about something, that thing that you initially thought of is called alternative hypothesis. Then you have to contradict your initial thought. In contradicting it, we are talking about the null hypothesis. This hypothesis, the alternative hypothesis, comprises of this sign. When you are setting the hypothesis, when you see not equals to, it indicates the two-state test. Not equal to sign indicated two-state test, while less than sign left-state test, and the greater than sign the right-state test. So also, these are the associated signs that the null hypothesis comprised. We have equals to, less than equals to, or greater than equals to. Whenever you are setting the hypothesis, so all these signs must be put into consideration. And we have three examples on this topic here. Firstly, we are going to deal with the two-state test or non-directional hypothesis. Non-directional hypothesis. So from the question here, I will explain why this test is two-state test or non-directional hypothesis. A company claims that the average lifespan of a battery is 60 hours. A random sample of 40 battery had a mean lifespan of 48 hours with standard deviation of 4 hours. So we are told, test the company's claim at a 5% significant level. Now the company was sure about the lifespan of its battery that is produced. That is, it said that the lifespan of its battery is 60 hours. Now, the random sample of 46 was taken out of a population of the battery produced, in which, after testing the lifespan of each battery, they found that the majority of battery now falls into 48 hours as their lifespan, with this standard deviation 4. Now, before you start the solution, solving the problem, you have to extract all the information that was given to us out. So our population mean is 60, our sample size is 46, as you can see in the question. For easier computation, then our sample mean is 40 with standard deviation of 4. Now the first thing to do when you are dealing with question in hypothesis is to first of all set the hypothesis. So this is our hypothesis now. Whenever you see this sign not equal to is 2 theta or no directional hypothesis, as you can see from here, it stated that the companies claim that the average lifespan of its battery is 60 hours. It's not telling you maybe it's less than 60 or more than 60. Whenever you see less than or more than, that one is either right test or left test. But this one is not even telling you any direction. That's why it is 2 test or non-directional hypothesis. Then in setting the hypothesis, we are going to set it this way because we don't know the direction of our hypothesis. So we now say that mu is not equal to 60 hours. Then now we are not contradicting not equals to by using mu is equal to 60 hours. The next thing to do in conducting hypothesis testing is to determine the test statistics. These test statistics will help us to make the decision coupled with the critical value in which we are going to see down. Now our S bar, which is sample mean, is equal to 48, then our population mean 60, then all over sigma over root n. This value sigma over root n is standard error. So we are still going to do that one in the next. We are still going to explain more about this standard error in the subsequent tutorial. Now our standard deviation is this. These are the computation. We have minus 20.3469. Now, so we need to convert this minus 20, this test as into positive by finding the absolute value. But if this value gives us positive value, there's no need of finding the absolute value. So far, find the absolute value just to remove the negative in front of this 20.3469. Now, this is the absolute value of the z-test. So 20.3469. Then we are going to determine the level of significance. Now we are told that at 5% level of significance in the initial question, but whenever you are dealing with 2 t-tests, the level of significance has to be divided by 2. That is why we say alpha over 2, which is equal to z 0.05, which is the initial value that was given to us, divided by 2, and it gives us 0.025. Now you now check the value the value of this 0.025 in the statistical table. So the value gives us 1.96, which is the critical value of this value. So this is the value in the table. So, and when in that wise, our test statistics is greater, absolute value of test statistics is greater than the Z critical value, which is 1.96. So the next step is to make decision and conclusion. Now, since Z critical value 1.96 is less than absolute Z test, which is 20.349, just a mistake here. So I'm referring to this value. Just a typographical error. So I'm referring to this value here. To absolute value of Z test, the null hypothesis is rejected, and when we reject the null hypothesis, that states that the lifespan of the battery is 60 hours. So we are accepting this one, the alternative hypothesis. We are accepting the alternative hypothesis that we are accepting this alternative hypothesis, which means that the lifespan of the battery is not 60 hours. So I will conclude, since Z critical value 1.96 is less than the absolute Z test 20.369, so I'm referring to this one 20.3469, the null hypothesis is rejected. I conclude that the average lifespan of his battery, that is the battery that the company produce, is not up to 60 hours. So that's that about the 2T test. Now we are now moving to another 1T test, which is right T test. Consider this question now. A farmer claims that the average weight of his tomato is more than 300 grams. More than is greater than. So this one is our greater than sign faces the right hand side of our arm, just to understand it, while the left one is the less than sign is our left T test, but here we are talking about the right T test, more than, that is greater than 300 grams. Now say that a random sample of 35 tomatoes has a mean weight, that is the sample mean of 205 grams with a standard deviation of 25 grams. Test the farmer's claim at 5% level of significance. Although we are making use of 5% level of significance, we can make use of 1, 2.5 or 10%. It depends on the requirement of the experimentalist. So, but for this tutorial, we are making use of 5%. And now, so like I said earlier on, you have to bring out the parameters. Our mu is 300. Then our sample size is 35. Our sample mean is 25. Where our standard deviation is this. Then the next thing to do now is to consider the hypothesis. And the first statement, any statement that has been said like this, more than, is considered to be your alternative hypothesis. That's why we have this sign greater than here. Then you can put equals to here, but want to contradict this greater than by putting less than or equals to. It's usually like that. You can put equals to, but don't put greater than equals to. You have to be opposite of this greater than sign. So in order to contradict the thought or the guess of the manufacturer or the farmer. Now the test statistics now. So as we did initially, so this is our answer. We have to, for the Z test, so we have to look for the absolute value of the Z test now, like I did in the initial example. So it gives us 22.4811. Then our level of significance alpha is 5%, which is this 0.05. Then this critical value for this test, if you check on the statistical table, we are having 1.645. Now we are going to make the next step is to find the make decision and conclusion about the claim of the farmer. Now, so we now say, since the critical value 1.645 is less than the absolute Z test 22.4811, the null hypothesis is rejected, and conclude that the average weight of his tomato is more than 300, which means that the farmer claim is right. His claim is very right. So the claim is very right. So then furthermore, the next question is about the left-hand test. As you can see, the sample 3. Left it there. Let's follow the question. A manufacturing company claims that the average time it takes to assemble a machine is less than 5 hours. In the initial question, to get it right, more than everybody knows greater than. Then here the first question, the question was not even specify any direction. That's why we know it's a non-directional hypothesis or two-stage test. But the second question was telling us more than, which is right-stage test, and the last question is telling us less than, which is left-stage test. So whenever any question arises, check to know the actual test you want to conduct, either non-directional hypothesis or left-stage test or right-stage test. The non-directional hypothesis is commonly known as a two-stage test. Now let's read the question again. A manufacturing company claims that the average time it takes to assemble a machine is less than 5 hours, which is left it there. A random sample of 30 assembly has a mean of 4.8 hours with a standard deviation of 0.5 hours. Test the company's claim at 5% level of significance. Like I said earlier on, all the 3 questions here we are going to make use of 5% level of significance. Then it depends on the experimental preferences. We can use 1%, 10%, 2.5%. It depends. So don't believe that 5% is constant level of significance. You can use, it depends on how the question was formed. Now, like I said, we have to bring out all the parameters. Our population mean is 5, then our sample size is 30, then our sample mean 4.8, as you can see, 4.8, then our sample standard deviation is 0.5 R. Now the first thing to do is to set the hypothesis. Like I said earlier on, you have to set the hypothesis. So far we are dealing with left-stage test. So our mu is going to be mu less than 5. Our null hypothesis is going to give us mu greater than or equals to 5. Then the next thing is to find our test statistics. So then some people can ask question that why are we not using t-test? Since our sample size is greater than or equals to 30, in statistics we believe that when a sample size is greater than or equals to 30, it is believed that that population size is large, and in that case the test that we are going to use is z-test. Just like the central limit theorem, as you are increasing the sample size, the population will be tending toward normal distribution. That is what is occurring here. When you make use of your central limit theorem, as you are increasing your sample size, the population will be tending towards normal distribution. So that's why we are making use of a test, z-test. But when our n, our sample size, is less than 30, so I have to remove this. Okay, less than 30, we can make sure for our t-test with some certain degree of freedom, in which in the next tutorial we are going to talk about the student t-test. It's almost the same thing, but the only difference is that the population is not up to, will not be up to 30. Now, having gotten the Z test, we have minus 2.1909. Then we have to look for the absolute value. Not in all cases that will be seen minus as a Z test, but whenever we see the minus test, I prefer converting to absolute value to make this value to be positive. So in order for me to easily decide either to reject or to accept the null hypothesis. Now, our level of significance again is 5%. So that's why we have 0.05. And the value of this 5%, when checking it on the statistical table, will give us 1.645. And having gotten that, this 1.645, you can now compare with this absolute value of Z test. Now, since we are now going to make our decision and conclusion, since Z critical value, which is this value, is less than the absolute Z test, the null hypothesis is rejected, and conclude that the average time it takes to assemble a machine is less than 5 hours. This shows that the manufacturer knows exactly what they are doing, because their guess was right through this conclusion. It's through this conclusion now that the proper planning can be made, because if otherwise happen, the wrong decision is going to be taken. So thank you all for listening to my tutorial. In the subsequent topic, I'm going to talk more about the hypothesis testing, because we have a lot of topics under hypothesis testing, particularly on the parametric statistics. We have analysis of variance test, we have t-test, chi-square test. So all these things will be dealt with in the subsequent tutorial, and later we are going to move to non-parametric test. Hypothesis is equally an hypothesis testing, but that one deals with non-parametric statistics, in which we are going to do the tutorial in a short while. Thank you all for listening to my tutorial. Thank you very much.